Welcome, everyone. My name is Jessica Bota, and I am the Project Manager on the Unified Terminology Governance Project, or UTG. This session will focus on the representation of HL7 terminology and the maintenance and publishing of the content. During this webinar, we'll look at the HL7 terminology website at terminology.hl7.org. We'll review the web page layout, including how to locate the latest published version of all content, or the current version of content, also called the latest in development. We'll look at where to find documentation and the terminology artifacts, and where to find content downloads. We'll then take a look at how the published terminology artifacts are represented and how to navigate to each type, as well as the useful groupings of artifacts. We'll then discuss the UTG vocabulary model. Next, we'll jump into the new Unified Terminology Governance process for terminology maintenance at HL7, including key highlights, scope, and external terminologies. And lastly, we'll look at how to locate and view existing vocabulary proposals and other content needs through the UTG Jira project on HL7's Jira site. We'll discuss how to review vocabulary change proposals that are in flight and how to report a content need or issue. HL7 terminology artifacts are accessible through the new HL7 terminology webpage at terminology.hl7.org. There was previously no simple way to browse the full set of terminology artifacts published by HL7. For those of you familiar with FHIR, the HL7 terminology pages should look and feel very similar, since the pages are built using the same tooling that's used to build the FHIR implementation guide. These pages are freely accessible to anyone with an internet connection or web browser. It's important to pay attention to the version of HL7 terminology being displayed on the pages. Terminology.hl7.org will always point to the most recent published version of the terminology, and the version is displayed across the top of every page. Across the top of the page, you'll also see a link for the directory of published versions. Clicking this link will allow you to see all previously published versions of the terminology, as well as the current version, which is continuously updated as changes are approved. You can view other versions by clicking on the links to the left of the version in the date column. For example, to see the current version of all content, click on the Current tab. This directs you to the set of pages to the version that you clicked on. In this case, we were directed to the current version, which we can verify at the top of the page. So we can see we're no longer on the published 1.0.0 version of content, but that we are now looking at version 1.0.14. The HL7 terminology pages include documentation throughout the tabs and subtabs that provide useful information in the context of each page. The home page introduces the Unified Terminology Governance process for vocabulary maintenance at HL7. It also describes the content layout of the site and the Unified Terminology Governance versioning approach. There's also a background tab that describes the architecture of HL7 content as published on these pages and each type of artifact that's browsable on these pages. There's also verbiage throughout the different artifact type tabs, as well as the grouping subtabs that provide information in context. The documentation is always evolving as part of the UTG update process. When downloading content, it's extra important to pay attention to the version of the terminology pages that you are on. Once you have verified that the version is correct, click on the Downloads tab. You'll be redirected to the Downloads page, which provides terminology download packages in several formats. The full content download contains a zip file of the HL7 terminology pages as they appear here. You can then host these terminology pages on your own network. There are also NPM packages available, and for more information on these packages, please see the FHIR documentation on NPM packages. For those using toolings that do not require NPM packages, you can download the artifact definitions, examples, and expansions in JSON, XML, and Turtle formats. The HL7 version 3 core MIF file is also available, and our hope is that other HL7 product family specific release formats will be made available for download in the future. The HL7 terminology is now represented as FHIR code system and value set resources. There are extensions in place to support the differences in design for the other HL7 product family artifacts. The design of value sets conforms to the characteristics of a formal value set definition normative standard. Naming systems are also provided as machine processable references for current and former identifiers for code systems or identifier systems. While there is a tab for concept maps, they're currently not published here. Concept maps are statements of relationships from one set of code system concepts to one or more other code system concepts. It's likely that they'll be supported once concept maps are normative in FHIR. The terminology artifacts are grouped by artifact type in the main gray tabs. They're separated into code systems, value sets, concept maps, and naming systems. Additionally, there's a number of useful groupings based on the artifact type. The groupings take into consideration the groups of artifacts that people tend to work mostly with based on how things have been published together for many years. The artifacts are grouped mainly for convenience, and artifacts can be in multiple subtabs. You simply click on an artifact link to go to the rendered page for that vocabulary artifact. On the right is an example of a code system on the HL7 terminology pages. For each artifact, there's three main portions of the page when viewing any code system or value set. The first is the summary, or the metadata. The second section is the content, which includes properties and codes for code systems, and logical definitions and expansions for value sets. And the third section is the history. In addition to metadata information like URL, version, name, OID, and others, the summary section provides links to source files for the artifact in XML, JSON, and Turtle formats. This may be useful for people wishing to download a copy of a single artifact without having to download the entire package of content. The summary section also includes links to other artifacts referenced by the selected artifact. For code systems, the references section will link to the referenced value sets that are cited on this set of pages. For value sets, the section will list code systems that the value set includes contents from. You can navigate to the reference content by clicking the link. You can then browse the referenced value set. The metadata is displayed similarly to code systems. You may notice that the value set references say it is not used here. That means it is not bound to data elements in the local implementation guide, because for UTG, there are no data element definitions, only terminology. So right now we have boilerplate text that we're looking into modifying or removing from these pages. The second section of a code system includes the properties used by the code system and the codes themselves. There are a lot of properties that are used throughout the artifacts, but most code systems use just a small subset of these properties. The codes are all displayed in the table below the properties, and there's a column for each property used in the code system. The level column indicates the depth of the codes if a hierarchy exists in the code system. All code system codes have display and definition values. The two properties are displayed in the last two columns, and I just want to note that there is a bug with the IG that does not display extensions like specializes and generalizes, and that's being worked on. For value sets, the contents include the logical definition and the expansion. The expansion is generated by the creation of these pages, so they're regenerated each time the pages are updated. The last section of a rendered artifact is the history tracking information. History tracking entries are added each time an artifact is updated using the unified terminology governance process. This can be useful for tracking changes to an artifact over time. We're looking into mining older history from the former publication process, and that might be added in the future as well. So that covers the three main sections when viewing code systems and value sets on the terminology web pages, as well as how to navigate the terminology site. HL7, through the Unified Terminology Governance Project, has collected HL7 terminology content and provides it in one location. This includes all HL7 content rooted in or having a URL that starts in http://terminology.hl7.org. It also includes some external content and CDA base as a subset of the v3 content. While UTG maintains the majority of HL7 content, there are some HL7 artifacts whose changes are not maintained by UTG. These include both code systems and value sets that are ballot-bound and will continue to be managed through the traditional ballot processes, including many artifacts from v2, v3, FHIR, and CCDA. UTG does not maintain many implementation guide-specific code systems and value sets. On the previous slide, I mentioned that UTG includes some external content. These code systems are maintained and published by other organizations. UTG provides a single place for HL7 required identifiers like canonical URL, OID, etc., and related code system information needed by the HL7 implementation community. HL7 does not maintain the content in these external code systems, but in some cases, HL7 has negotiated permission to republish external content. Most of these external code system resources, often referred to as code system stubs, do not provide any coded content. The actual coded content needs to be obtained from the publisher listed. The code system stubs also provide the identifiers used to reference the code systems in HL7 implementations. The handful of external code systems that HL7 has agreements to redistribute a subset of their content through UTG are present for the convenience of the HL7 implementation community. One example of this is Snowdent, and others may be considered based on need. The HL7 terminology also includes naming systems, which are used to keep track of historical and superseded identifiers for code systems and value sets. There are UTG naming system resources containing this information for all external code systems. The HL7 terminology uses a three-part release identifier in the format major, minor, and patch, represented by integers. Each published release, current build, and terminology artifact have a version in this format. For builds, releases, and current, the version ID refers to the content of the aggregate. The major number is incremented when a new release is done, and the current build carries the same major number as the most recent release. The minor number is incremented only under special circumstances. A patch number is incremented for each current build, but is rarely used for a release. Each individual vocabulary artifact also carries its own version. Those versions are updated according to the Vocabulary Working Group versioning policy. For example, adding a code to a code system would be a major change, while editing some of the metadata fields would be a minor change. Fixing of typos and technical corrections would be a patch. More detailed information about the versioning policy will be included in the upcoming session geared towards vocabulary change proposal submitters. The UTG model provides a common architecture for all HL7 content in a familiar format. The UTG model aligns with the definitions of the FHIR normative code system and value set resources, the FHIR naming system resource, and the FHIR list resource. In addition, a set of UTG-specific extensions and properties have been identified to support alignment between FHIR and the v2 and v3 terminology models. We have created internal coded content for this and to support maintenance. These extensions and properties allow us to maintain older information as published in the HL7 product family terminology structures for many years. Having a uniform content representation makes it possible to have a single process to maintain and publish all of the HL7 terminology. This will also facilitate the ability to unify content across the HL7 product families in the future where appropriate. UTG has imported the underlying code systems and value sets from the v2 publishing tooling, making them available to browse and maintain. A unique aspect is that the data specific to the v2 tables is now represented as a single code system for the table metadata. Each concept in this code system has an extensive set of properties to hold all the table metadata as published in the v2.9 normative standard Chapter 2C tables, including the associated concept domain, code systems, and value sets. One benefit about this representation is that the V2 tables are no longer a special and different kind of terminology artifact. They are represented as a standard FHIR code system and fully browsable in the same way as all of the other UTG content. UTG has imported all code systems, value sets, concept domains, and bindings published in the V3 core MIF. This is represented using extensions and special concept properties to accommodate for the differences in the V3 model and the FHIR vocabulary model. All V3 concept domains are now represented in a single concept domains code system, where each concept domain is a single concept code. All of the bindings are represented as properties on each concept, with all HL7 binding realms represented in a single code system of binding realms. On the previous two slides, I mentioned we needed to create special properties to represent tables and concept domains, which don't exist in the FHIR vocabulary model. We defined infrastructure vocabulary to help support these special representations. The second purpose is to support special workflows, such as the handling of normative ballot-bound vocabulary. In order to facilitate the implementing of special software for these workflows that are internal to UTG, it made sense to create specialized code systems and concept codes to support this. The two major examples of the infrastructure vocabulary are the concept properties code system and the maintenance infrastructure code system, which are part of the unified set of code systems. There are additional infrastructure code systems like HL7 workgroups and HL7 realms to support different workflows and representations. The image below shows a few examples of the concept properties that help us to represent V2 tables. Note that the concept properties are represented as codes in a code system. Now that we have seen the representation of the content, we will take a look at how these vocabulary artifacts are maintained using unified terminology governance. Understanding the unified terminology governance process is important since it gives some insight into how these terminology pages are updated when vocabulary changes are needed. The transition to the UTG solution for vocabulary maintenance at HL7 from the previous harmonization approach introduces several beneficial changes. First and foremost, all published HL7 terminology artifacts are now accessible and browsable in one place. There's no need for bulky downloads or installing tooling to browse the content. Vocabulary maintenance is also a continuous process. Harmonization used to occur 3 times per year, which led to delays in implementing vocabulary changes. With the rapid development of implementation guides, it's really important to be able to push changes through more quickly to support the implementer community. And with this process, changes can be pushed through on demand. The UTG vocabulary maintenance process relies on a Jira-based ticketing system that supports the workflow needed to implement vocabulary changes. Previous requests were created using Word documents, GForge tickets, and emails, so there never was any transparency or central repository to see all proposals. The UTG process uses platform-independent tooling so that the vocabulary change submitter can create the terminology changes. Changes were previously done using rich text editors, which often led to typos and errors in the content. The vocabulary change proposals go through a consensus-based workflow where reviewers can vote on the approval of changes. Once requested changes are approved, changes are managed using Git and Subversion. Through this process, all artifacts are versioned and change managed independently. These improvements provide a more responsive and transparent method for vocabulary maintenance that we believe will benefit the community. The vocabulary issues and change proposals are all entered and managed within the HL7 Jira environment, and more specifically in the UTG Change Proposal, or UP project. Each set of HL7 terminology change proposals are managed as a single Jira issue, or ticket. The only requirement to view the vocabulary tickets is a Jira login, which HL7 members should already have. We'll cover some basics on searching in Jira, but since Jira is a widely used tool, there are many great resources to help with issue searching in Jira. HL7 provides links to some of these helpful resources on the HL7 Confluence homepage. To navigate to the UTG tickets, log into the HL7 Jira page at jira.hl7.org. Click on Projects on the top bar of the page and then select View All Projects. From there, select the UTG Change Proposal project. Since there's a large number of projects hosted by the HL7 Jira site, you may need to go to the second page to find the UP project. Clicking on the project name will bring you to a page that by default lists all open issues. Within the UTG project in Jira, there are two different types of tickets. All HL7 members with Jira logins will be able to view these tickets. The first type is the identified content issues. These are open issues or new needs for the HL7 terminology that have been reported but do not document a solution. These types of issues will sit in the queue until someone takes responsibility for providing a solution as a vocabulary change proposal. Content issues are identified by being in the Waiting for Input Jira Workflow state. The queue of content issues exists to keep track of items that need to be addressed at a later date. The second type are vocabulary change proposals, which are tickets in the consensus review state, which provide a fully defined solution to a terminology issue or need. This solution includes all proposed content changes to the terminology artifacts in UTG. These are rendered in the same way that the HL7 terminology artifacts are on their own build page. These tickets may be reviewed and voted on, and if approved, the proposed changes will be implemented in the current build. The change proposal and content issues tickets take the same workflow paths through its life cycle. We will focus on the major pathways, and if you're interested in learning more, all workflow states will be covered in the upcoming reviewer tutorial. Once a change proposal or content issue is created, they start off in the environment setup workflow state, where the tooling environment can be updated if needed. From there, the submitter will either draft a proposal, changing the state to proposal draft, or mark it as a content issue, which will change the state to waiting for input. From there, a submitter can draft a proposal once the design solution has been determined. Once the proposal has all relevant information along with the proposed changes, the ticket can be submitted, and it goes into the submitted state. The terminology curator will perform validations in the content check state, and if it's okay for review by the HL7 community, it gets pushed into the consensus review state. At this time, the proposal is open for voting. Based on the number of positive and negative votes, the proposal will either end up in the proposal implemented state if it's approved, or the change rejected state if it is rejected. The only other final state is withdrawn if, after the reviewer comments, the submitter decides the changes are no longer needed. The Jira search functionality is helpful for locating tickets in a particular workflow state. To search by workflow state, click the View All Issues and Filters link at the top right of the UP project. This enables the advanced search options on the top of the page. Filtering to a workflow status is as simple as selecting the status dropdown and selecting the status of interest. For example, if you're looking for identified content issues, click on the Waiting for Input checkbox. Or for vocabulary change proposals, select Consensus Review. You can search for any of the other workflow states depending on whether or not you find it useful. As we just saw, searching for tickets in the Waiting for Input state will provide us with a queue of open content issues. This queue is really just a list of content issues so that they're not forgotten. In order to fix these content issues, a solution must be provided by a vocabulary change submitter. This is also a good place to search if you notice a vocabulary issue and want to check whether or not it has been documented. This can be done using the simple search in Jira by searching on strings related to the identified content issue. On the example on the right, we can see a summary about the content issue at the top of the ticket. In the details area below, we can see a lot more information about the ticket and are able to easily tell that the ticket is a change request. Tickets can either be change requests or technical corrections. Technical corrections are only to be used when an error has been introduced by process or tooling, and the error must be corrected to bring the source of truth back into alignment with what was decided in consensus. The priority field is for expected future need to have increased focus on certain proposals that are in a time-critical path for other important HL7 activities, but is not currently being used. There may be a label which allows categorizing tickets and facilitates searching. This may be important as the number of tickets increases dramatically. The status and resolution are also displayed. The proposal's description describes the content issue being documented by this ticket. The sponsor field indicates the HL7 work group that would be best to suggest a solution. The change object field lists the URL of any existing vocabulary artifacts that are related to the content issue or need. You can click the link and go directly to the current state of the vocabulary artifacts, which can be helpful for seeing the content issue in context. And lastly, the proposal type indicates the product family of the content in which the issue has been identified. Now that we've looked at a content issue ticket, we'll cover how to enter one. If you're interested in entering a vocabulary change proposal, there will be a following session covering the requirements and instructions on submitting those. The first step when entering a content issue or need ticket is to search within the UTG Jira project to ensure a ticket doesn't already exist. Use the search bar at the top right of the page to enter keywords relating to the issue or need. If no existing ticket exists, you can proceed with the creation of a new one. To initiate the creation of a content issue or needs ticket, once you're within the UP Jira project, click the blue Create button on the top bar. This will bring up a form that will be submitted as the ticket. All fields that are required are marked with a red asterisk. You'll not be able to submit the ticket until those fields have been entered. The fields should all look familiar since we've seen them in the previous examples on the slides. Select either change request or technical correction based on the issue being reported. The summary should be a brief description about the content of this proposal. This will serve as the title in UTG to help find the right proposal, so make sure it's short but meaningful. Then enter the sponsor of the proposal. This could be an HL7 working group or an external group, such as the Gravity Project. Then select the product family that the proposal is related to. The selected product family should be the tabs where the artifacts are currently hosted on the HL7 terminology pages. Next, we enter the proposal description. This should provide the overview of the request, including the problem statement. These descriptions should be concise and to the point, and you must provide the reason that the change request is needed. If the proposal is related to an existing vocabulary artifact, enter the canonical URL of that artifact. You can enter multiple as a space-delimited list. Lastly, select the assignee. If left on automatic, the proposal will be assigned to the person entering the ticket. You can also select another user to assign the proposal to. In many cases, the person entering the ticket may want to assign it to someone who has the submitter role so that they can propose vocabulary changes and push it through the workflow to be implemented. The dropdown for assignee is limited to those with submitter role only. Once all of the required fields have been entered, you can go ahead and create the ticket. It will now have its own unique ticket ID, and everyone in the HL7 community will be able to view it. Just keep in mind that it will remain in the waiting for input workflow state until someone with the submitter role takes responsibility for it and specifies the proposed change details. The list of vocabulary change proposals, or those in the consensus review workflow state, includes tickets that have proposed changes to address content issues or needs. Before entering consensus review, these tickets will undergo technical review and oversight by the terminology curator, who is notified when proposals are submitted. The terminology curator is responsible for checking the proposals for any critical issues. If none are found, the Terminology Curator will create the vocabulary changes included by the submitter as browsable web pages in the context of the rest of the HL7 terminology and push the ticket into consensus review. These proposals include one-to-many fully specified and designed changes that were drafted by a submitter who has special Jira permissions that allow them to submit vocabulary change proposals. Submitters are familiar with the tooling and processes required to perform these activities. Once the vocabulary change proposal is in the consensus review workflow state, the ticket is available to the community for review. Reviewers can make suggestions and ask questions using Jira comments, eliminating the need to set up scheduled calls to discuss the proposal, and they may cast negative or affirmative votes to progress the proposal. The details for voters will be in the upcoming reviewers tutorial. On the example ticket on the right, you'll see the same fields that we saw in the identified content issue ticket. However, there's one additional field for the published example. Clicking this link brings you to the generated web pages that include the proposed content. It will direct you to the entry page, so you'll have to navigate through the tabs and subtabs to locate the vocabulary artifact. Note the version at the top since it indicates the build version the changes were created from. It also indicates the ticket number. In this case, we can use the information provided in the ticket to help locate it. The Change Objects field in the ticket indicated that we need to find the V2 tables code system. So we'll start by selecting the Code Systems tab, and then the V2 tab to filter on only V2 content. Lastly, we can select the V2 tables code system. This page shows the entire vocabulary artifact, including the content changes made by the submitter. In this example, we'll look for the concept that represents Table 129. Scrolling to the right to see more properties, we can see that the PV2 has been added for this table. This allows reviewers and other interested parties to visualize the changes in context without having to download any tooling. There'll be another session focused on vocabulary change submitters that will provide training on how to draft and submit a proposal. If you find a ticket that you're interested in and would like to follow it throughout its workflow cycle, you can sign up to be a watcher. Watchers receive an email whenever a change is made to the ticket. This includes descriptions and other field changes, when comments are made, or when the workflow status is changed. This can be really helpful for those changes you are particularly interested in, as it will notify you when the changes have been approved, and again when those changes have been implemented in the current build. It will also notify you if the proposed changes are rejected. To watch a change proposal or content issue, open the ticket that you're interested in watching. Then look in the section labeled People and click on the Start Watching This Issue link. You will now receive emails to the address used for your HL7 Jira account. This is an example of an email that a watcher would receive. In this instance, the submitter did not include the proposed vocabulary changes and is being told to resubmit the ticket with the changes. Once a change proposal is in consensus review, there are a handful of possible outcomes. The first is that there is consensus and the change proposal is approved. In this case, the design changes are implemented to the current build of the HL7 terminology. The changes are released in a short period of time, and watchers are notified of the release. The content will be available in the HL7 terminology and the terminology pages as soon as those changes are implemented and released. It's also possible that the proposal could be rejected by the community. In this case, the ticket is archived and all information is maintained for future audits. Watchers are also notified that the changes will not be implemented. Sometimes a change proposal contains errors or did not completely or correctly include the proposed changes. The ticket can be revised and resubmitted with corrections. It's also possible that the change proposal is no longer needed. The ticket is then withdrawn and the ticket is archived. Throughout this session, we focused on accessing and navigating the HL7 terminology pages that include HL7 terminologies in one centralized location. We then learned about the unified terminology governance approach for vocabulary maintenance at HL7 in which vocabulary changes can be requested, reviewed, and voted on at any time, rather than depending on a calendar-driven process. Depending on the HL7 community's level of participation, the requested changes can be approved and implemented in the current build in as short of time as a few days. The documentation and tools required to submit a vocabulary change proposal are all freely available on the HL7 UTG Confluence pages. If you're interested in submitting a vocabulary change proposal, there will be a future session that focuses on the details for submitting. This is highly recommended for anyone wishing to submit a proposal, as it does require specific tooling and procedures. For those wishing to review and vote on proposed changes, there will be a training session focused on the details of reviewing, commenting, and voting on proposed vocabulary changes. That concludes this session, and I hope it sheds some light on the new HL7 terminology web pages and the unified terminology governance process. I encourage you all to browse the web pages and the UTG Jira project at your convenience. Thank you.